Chapter 5 of Intrastats 5th edition focuses on the use of the standard deviation, that measure of how far away an observation is from the mean, and something we'll introduce as the normal model. And this is done through some examples where we want to compare performance. So the key aspect of this is to think about a standardization. If we take an observation y, if we subtract off its mean y bar, we divide by the standard deviation s, we get this standardized score. And that's going to be a way we can compare apples to apples. This idea of shifting and scaling we can do in various other kinds of ways, and section 5.2 describes about it, and those will allow us actually just to rescale, create these ideas of things called z-scores. So the normal model part may be new, so I wanted to kind of take a moment to talk about how important it is, because it ends up arising in all kinds of situations. And there's something called the empirical rule, or the 68, 95, 99.7 rule, which tells us a lot about the normal distribution. So a Gaussian or normal model will have about 68% of its values within one standard deviation. That's going from a z-score of -1 to 1. 95% within two standard deviations, and almost all, or 99.7%, within 3. So if things are plausibly normally distributed, it tells us a lot about how to do that. So I definitely recommend going through some examples to kind of explore this. Doing the just checking is always a good idea. These just checking problems are available, the answers are available at the back of the chapter, but it's really helpful just to be practicing to make sure you understand how things are working. The advice here when working with normal models is sound, make a picture. It's going to be very, very helpful as you start to go ahead and explore stuff. We can work back and forth with something called normal percentiles. We'll talk about how to do all this in R. It's actually going to be very straightforward. There is a table in the back of the book, but it's not something we'll ever have to use. We'll always be doing this using R as a way of calculating those, with the exception of the empirical rule. Section 5.5 talks about the use of normal probability plots to try to judge whether a distribution, here's an example of the miles per gallon, which is actually reasonably normal, another distribution here where it's not, and you can see the normal probability plot tends to be straight in the first and not in the second. So there's some nice connections here, what not to do always provided, and a chapter review. Implementing things in R, there's really not much new here, so this is the IS5 in R, chapter 5. We go ahead and read in the data. We can go ahead and calculate some various plots. We can go ahead and do the shifts using various functions, such as mutate, to be able to go ahead and create new values for us, and rescaling. What's really new that you may not have seen before is the use of the XP norm function. And that can be used to kind of help us to see what's going on. If we have XP norm, the first argument that is a particular value, it can tell us to calculate the probability to the left and to the right of that particular value. Here we're giving a bunch of these values as a way of generating a picture of what things look like for that normal distribution. If we run that in some other ways, we can get some different examples for this, either specifying a particular mean or making it the default, which is mean 0, standard deviation 1. Again, practice is really helpful for the 68, 95, 99.7 rule. That'd be my advice for this chapter.